All right, y'all. So we're moving into a new unit here. We're going to start polynomials. Now, as a reminder of what a polynomial is, okay? So it kind of comes from that, root word poly, okay? So which is multiple. All right. So with multiple, okay, this is essentially an equation or an expression really that has multiple terms, okay? So multiple terms. And I'm going to try not to say okay a lot. I've been told that I've been saying okay a lot in my videos, so I'm going to try not to do that today. With multiple terms, okay, so, and there it is. But anyways, all right, multiple terms. So maybe it's something like 2x cubed, okay, minus x squared plus 6x plus 10. The multiple terms are these parts here. Right? It's the parts that are essentially separated by adding and subtracting. Okay, so that's what those are from. So you know what a polynomial is, and again, it's the multiple terms aspect of an expression. Okay. All right. So solving by factoring. Okay. So the one thing that we're going to kind of work on today with polynomials is kind of a review of factoring, and then also multiplying polynomials. Okay, and then the quadratic formula and a few other things. All right, so let's talk about our first step. So this is a flow chart. Okay, so you start kind of at the top and then you work your way down. So we always want to look for and factor the GCF. Now let's talk about what a GCF is. GCF stands for greatest common factor. Okay, now we will get into kind of what that looks like when we get there. But for now, let's just go through the flow chart, and then we will we'll see examples of each of these. Okay, so greatest common factor there. Two terms. Okay, from here, essentially you either have two terms or three terms. Okay, now technically this is not always the case. All right, but for factoring purposes. If you're kind of attempting to factor a polynomial, you're typically going to have two or three terms. Okay, but just understand that a polynomial can have 12 terms or something like that. But when we think of factoring, we want to look at it in terms of two or three terms. Okay, now two terms is what we call a binomial. Three terms, we'll call that a trinomial. Cool. Okay, when it's two terms, okay, this is what we call difference of squares. Okay, if something is factorable, all right, you're going to have, and it only has two terms. If it's not a GCF, okay, it is difference of squares. All right, now what a difference of squares is going to look like. Okay, it's going to look like something in this form, a squared minus b squared. Okay, and now in order to factor that, I'm going to have two different things. Essentially, I'm going to have a plus b, and I'm actually multiplying that by a minus b. Okay, now we can think about why this is the case. All right, and honestly, probably the easiest way to think about this would be to get from here to this, from this right side to the side on the left. Okay, because essentially what we're doing is we're multiplying it out. Okay, let's just go ahead and look at this one. Let's just kind of get some quick practice in with multiplying this out and see why it equals this. Okay, so I like to use the box method. I'm a big fan of the box method. I think it's organized, it's nice and neat, it's a visual reminder of what we're doing. So it's a plus b, okay, and then times a minus b. Right, and so this is two binomials, and we're multiplying these out, and we're going to see why we end up with a squared minus just b squared. I've got a times a, that's a squared. Okay, and then I've got negative b times a, so that's actually negative ab. Okay, then over here we've got just ab, there's ab, and then plus and minus, so that's going to give me a minus, and then b times b, which is b squared. Okay, now here's the weird part. Okay, notice that what we have to do is we have to combine these two, okay? But when we combine them, what do we end up with? Well, they end up canceling each other out, right? Because I'm adding up all these. I've got a squared plus ab, okay, minus ab and then minus b squared. But these two get me 0. So I'm just left with a squared minus b squared. Okay, so that's kind of where it comes from, right? We're just looking at, how do we get this? Well, it's the difference between what factoring and multiplying is, right? If we started off with this, we could get this. All right, if we're starting here, what I'm telling you, right, part of the factoring is we can get to this part. Okay, so sometimes factoring is advantageous. It has its advantages, right? It can help us solve for x and different things like that. So that's why factoring comes into play. Okay, now keep in mind, these are polynomials, and it may not always be a and b, right? It could be like, instead of a, it could be 2x, right? Or, b could be 9 or something like that, right? And then we would notice that in place of everything, right, this would be 2x, this would be 9, and then you would kind of replace it in order to actually solve it. Okay, that's kind of the general form of what difference of squares looks like. Next, perfect square trinomial. Perfect square trinomial. I like to think about this kind of the opposite as a difference of squares, and you'll kind of see how these relate. All right, if you have something that is in this form, a squared plus 2ab plus b squared, so you can kind of see the similarities, hopefully a little bit, right? I've got a squared, this time I'm adding b squared, okay? But this is the perfect square trinomial. We'll kind of see the relationship between these two. Okay, and that is equal to, that's a plus b, squared. Okay, and so what I'm doing here is I'm doing a plus b, right? And if we were to go back to the box, instead of this minus here, I'm going to have a plus, all right? And I would get out this, right? We could do the box method again to verify this if you wanted to. Okay, but we're not going to go ahead and do that. So it could be either it's this, right? A plus b squared, right? It's the same thing squared, and we get this. Okay, another option for this may be that you have a squared minus 2ab, okay, and then still plus b squared, all right, and that would equal a minus b squared. Okay, and remember what we're doing, right? This is a minus b squared. It's a minus b times a minus b, and we would get out this. So if we have something in this form, right, we've got something squared minus 2 times each of these, and then plus b squared, we could factor this out into this right here, and that is our perfect square trinomial. Again, a and b could be different things. A could be 2x, right, and just to stay consistent. B could be 9, right? So if I were to plug it into that, right, if it was 2x here and then plus 9, okay, it would be 2x parentheses squared, okay, and then plus, and we just continue to plug everything in where a and b lie. So that's one example of when you have 3 terms. Okay, so maybe it's a perfect square trinomial. It might not always be the case. Okay, another form that you may see this in is where you've got a 1 out in front. Okay, 1, and then maybe that 1's invisible, right? You do not have to write that 1, but I'm just showing you that your leading coefficient here is 1. Okay, and then plus bx plus c. Okay, now this could be factored into, well, those examples, hopefully we can kind of remember these, right? Sometimes people get a little bit confused with the perfect square trinomial, the difference of squares, but this should look pretty familiar. You've done it in Algebra 1, you've done it in Algebra 2. Okay, so this is your kind of classic factoring where you split immediately into 2 parentheses like this, okay? And then you get an x and an x, and then you've got something here and something here, okay? Now, those somethings, let's go ahead and talk about what those are, okay? We want the something times the something, okay? First something, right? This is that one, and this is that one, okay? We want the something times the something to equal C. But we want the same something plus the second something to equal B. Okay, so let's just do a quick example, all right? Let's see, let's do, if I had x squared, all right, plus 9, okay, and I had 10x here. No, let's do, yeah, no, that works. Okay, so x squared plus 10x plus 9, and I asked you to factor this. Okay, well, the first thing you're going to do is you're going to split it like this. Okay? And we put the x, and we put the x. And now, what I'm doing in my head is I'm thinking, okay, I know I need a something here and a something here. What I multiply has to be equal to the 9, has to be equal to my c. Okay? And then when I add those two somethings, they're going to have to equal my b. Okay? So you could fiddle around with this, right? You think about the factors of 9. Okay? 9 can be split, as, it's either 1 times 9, it's either 3 times 3. Okay? Maybe depending on the number, you've got multiple. Okay? But those are really your only options here. You got 1 times 9, 3 times 3. Okay? So in this particular example, let's try the 3 times 3. 3 times 3 does equal 9, but 3 plus 3 does not get me my b, which is 10. Okay, so this particular one, it's plus 1 and then plus 9, and that's the factored version. Okay, so again, you're going from a trinomial to the factored version. And now the factoring version, again, has huge advantages for us at times. Okay, sometimes we want it in this form, sometimes we want it in this form. Okay, it just depends on the type of problem. Now, let's just go ahead and do this, right? One example where this is huge for us to have is when we're trying to solve for when it equals something. For this expression, when does that expression equal 0? Well, the reason we factor it is because that's probably the quickest way to do it. Okay, you factor it, you got x plus 1 plus x plus 9, so you split it into 2. Okay, and then you split it into 2 to solve it. So you've got x plus 1 equals 0, x plus 9 equals 0. And then we subtract 1, x is equal to negative 1, and then x is equal to negative 9. Okay? So that's where that kind of comes into play. That's where it's better for us to have it in factored form. Okay? Now, keep in mind, you maybe, depending on the problem, right, it's like, find what this is equal to, right, or FOIL it. In order to get from here to here, that's where we're going to use the box method. Okay, that would be foiling or the box method, whichever you prefer. All right, cool. Last one on the trinomials. Okay, what if you have an a value out front this time? Okay, that's not 1, right? It could be anything but 1 here. So ax squared plus bx plus c. All right. Now this one's a little bit different because you're going to have one of them that has ax and then one that just has x. All right. And then you've got something here. Okay. And then we want. Okay. What we want here is we want the blank. Okay. We want the blank times the blank. Okay. To still equal c. Okay, because that's that last part of the FOIL, right? First, outside, inside, last. The last times the last, still we want to be equal to c. Okay? Then you have a little bit of a different part. You've got the outside and the inside that you still have to talk about. So that's multiplying. Multiplying this times this gets you the inside. Multiplying this times this gets you the outside. Okay? Now it's going to get a little bit crazy here, but I'm going to go ahead and label that. That's my outside. Okay, that's my inside. Okay, and what I want is I want the inside plus the outside to equal b. Okay, whatever my b happens to be. Okay, and that's examples where, I guess quickly, I'll go ahead and do one. These are a little bit hard to get immediately, but let's do 3x squared. Okay, let's do plus 10. All right, and let's do this. Let's do plus 11x. Okay, so let's try this one. 3x squared plus 11x plus 10. Okay, so the first step, I'm going to split it. I've got 3x, okay, and then I close it, and I've got x. Okay, I'm not even going to worry about the solving for 0. We're just doing 3x squared plus 11x plus 10. Okay, and maybe let's get a little bit closer so it doesn't look as funky over there. Okay, so you were given this. Okay, and let's say the problem is asking you to factor it. Okay, well, the first thing I'm going to do is I'm going to do kind of what I did with that 9, right? I always start with my c, me personally. Okay, this is not the only way to do it, but it's usually the best way, in my opinion. Okay, so you want to look at your factors for C. All right, well, let's think of some factors of 10. So 1 and 10, okay, you've got 2 and 5, okay, and really that's it. I always think there's more, but it's just those, right? 1 times 10, 2 times 5 for this one. So you could try each of these options, okay? Now we could, there's multiple different ways to do it, right? Because you could have, you could have the 10 here, right, and the 1 here, or you could have them switched. Okay, and then with the 2 and the 5, right, you could have +2 here, +5 here, or you can have them switched. Okay, keep in mind, you might even have a negative in here. Okay, and if you've got a negative, now, or negative here even, right, then you've got to switch it with the positive and negatives to kind of play around with them. Okay, but for this particular one, okay, let's just toss it in, right, and see if it works. You just have to kind of fiddle with these, to be honest, right? You got to try it, and you got to use your multiplication skills to kind of think about which one would fit. Okay, so maybe you're fiddling around with it, you realize 1 and 10 don't work, you realize 10 and 1 don't work, you realize you kind of keep messing with it, and then you get to this right here, and you see that it would be +5 here and then +2 here. Okay, now what you want, again, is you want the outside parts plus the inside to equal b. So let's try it out. What's 5 times x? Well, it's 5x. Okay, what's 3x times 2? Well, that's 6x. So because 5x plus 6x does equal that 11x, we know that this is my factor form. Okay, all right. So that's what I mean by having that a outside. These are make it a little bit more complicated, so just don't forget that. All right. So those are your trinomials. Those are your options for your trinomials. Okay, now check each binomial factor to see if it's a difference of squares. Okay, set each factor to 0 and solve. So that's kind of like that example where we now get it into the binomials, right? And what I mean by the binomial, right, is this a plus b, okay, a minus b, all these different things, all this in here, right? Those are the binomials. Okay, and then set each factor to 0 and solve. All right, so principle of square roots. Okay, this is essentially if you have something like this, if you have x squared is equal to a, right? Then in order to solve it, this is all this is saying. If you get something that looks like this, x squared is equal to 9, okay, or whatever it is, then you take the square root on both sides. Okay, you're going to get x is equal to plus or minus the square root of a. All right, and that's all you're doing there. Okay, some people get confused kind of when we think about the factoring, right, is, oh, what do we do here, right? Well, we just solve, right? But that's the whole point of factoring, is to just solve for x most of the time. Okay? All right, quadratic formula. Let's say you tried all this stuff and you still can't factor it, okay? Maybe you'll find that you could put the, maybe you're like sitting there forever trying to think about how to factor it, and then you put the quadratic formula in and you get a whole number or a nice fraction. If you end up getting a nice fraction or a whole number, it's likely the case that you could have factored it the whole time. Okay, so you can use the quadratic formula to solve for x at any time, but we typically reserve it for times where we're not able to factor it. Okay, so the quadratic formula, okay, if the polynomial is in the form ax squared plus bx plus c, okay, the quadratic formula is that x is equal to negative b plus or minus a square root. I always forget it, to be completely honest. B squared minus 4ac. I like to factor. Factoring is way easier. And then all over 2a. Okay, so you literally take those numbers, you plug them in. Let's zoom in a little bit. You plug them in and evaluate. Okay, so if this was 3, 4, negative 9, you would take those values and you would plug it into the quadratic formula. You get out two different solutions. And keep in mind, you could potentially be taking the square root of a negative number, and when that's the case, you get imaginary solutions. Okay, so you always get solutions technically, but sometimes it's an imaginary number. Okay, all right, so that's the quadratic formula. So that is kind of what factoring looks like. Okay, We're going to do some examples, and then there's just a few I want to go over. Kind of sums that I guess we did one of each of these, but there's other ones that I want to talk about. And where's my sheet? Here it is. Okay, so the first one I want to do is, well, I just want to lay these out. Okay, I want to lay these out first. Let's talk about all the operations we can do with polynomials. Okay, so if you were to add or subtract polynomials, it's very simple. Okay, adding and subtracting polynomials is probably the easiest operation that you have with polynomials. All you do is combine like terms. That's it. Combine like terms. Okay, now remember, like terms, right? You've got like x squared. Maybe you got one x squared to the left, and then another x squared all the way to the right. Okay, so you can combine those because they both have x squared. So you want to look at what is a like term, and then you just add those up. Okay, I'm not going to go over that just because we're going to kind of cover that within multiplying polynomials, and that's the next one we're going to do. Multiplying polynomials. Okay, me personally, I like to use the box method, especially when they get a little crazy. Okay, so what if it was something like this? Negative 3x squared plus 2x squared plus 8x plus 2, and then times 3x squared plus x plus 4. Okay, so I see that we have a polynomial here and then a polynomial here, and we are asked to multiply them. Okay, so in order to multiply it out, I'm going to make my box. Okay, I'm going to write this out. I'm going to do negative 3x squared, okay, then minus 2x squared plus 8x, and then plus 2. Okay, so I'm going to make my box and save room for about 3 because we have 3 different terms here, right? 3x squared, x, and then 4. Okay, so here it is. All right, now I've got 3x squared, x, and then 4. Okay, and if it helps, right, because this didn't have anything out in front, don't forget you can put a 1 if you wanted. Okay, so here we go. First, I like to multiply my coefficients, so 3 times negative 3, that's negative 9. Okay, so you take care of those first, and then you're done with them. We've got x squared times x squared, that's x to the 4th. And we're just going to fill in each one. Okay, so we've got 3 times negative 2, that's negative 6. X squared times, that's, should be x, excuse me, this should be x cubed. X cubed, and then we're going to change that to x to the 5th. I apologize. Okay, so that initially should have been x cubed. Okay, so negative 2 times 3, and then we've got x to the 4th. Okay, 3 times 8, that's 24. X squared times x, x cubed. And then we've got 2 times 3, 6. And then we just leave x squared, right, because we don't have anything else with that one. Okay, next one, negative 3. All right, x to the 4th. Okay, negative 2, x to the 3rd. 8, x squared. And then 2x. On this one, negative 3 times 4, negative 12, x cubed. Okay, negative 2 times 4, negative 8, x squared. Okay, 8 times 4, 32, x, and then 2 times 4, 8. Okay, now what's nice with these is that when they're nice and laid out with like it kind of is decreasing the powers, like x cubed, x squared, x, and then constant. What's nice about that is that you can add them very nice and neatly with like this. Right? You notice these are like terms. Okay, so the ones I circled, those are like terms. Okay, now if the case is not so nice and neat with the kind of decreasing that I was talking about, it's possible you don't have that like nice little diagonal, and you've got to kind of find out which ones are your like terms. Okay, but there's only one x to the 5th. Okay, so we're going to go ahead and write that one. All right, and then we've got the x to the fourth term. So I've got negative 6 and then negative 3, right? I'm combining those two. Negative 6 plus negative 3. That's going to get me negative 9 x to the fourth. Okay, on this one, 24x cubed minus 2x cubed. So I'm now at 22x cubed. 22x cubed minus 12 plus 10. Okay, plus 10x cubed. Over here, these two cancel, right? 8 minus 8, 0. Okay, so I'm just, on that one, I've just got 6x squared. 32x plus 2x. Okay, so 34x. And save just enough room for that 8. That is your multiplied out polynomial. Okay, continuing on. It's nice to talk about those just because you kind of see where this comes from, right? And we can go back to here. All right, let's do a GCF problem. What if I told you to factor this right here, 2x squared plus 4x, and I asked you to solve for when that is equal to 0? The best way to do this, okay, and remember, if I'm thinking about my flow chart, the first thing I want to do is I always want to look for and factor the GCF, greatest common factor. Now let's talk about what the greatest common factor is. Okay, I've got a term here and a term here. And between those two terms, I have a common factor. I'm going to go ahead and tell you that. But the reason why I know is, look, I've got an x here and an x here. One thing that can kind of help you remember, like understand when it's not, or understand when it's not a GCF, is when you have a constant. If you've got a constant at the end, kind of like this, right? Like I had a constant at the end of this polynomial, or for this polynomial, right? I've got a constant at the end. There's no x term at the end there. Then likely you have a GCF type problem. Okay, so because I have an x here and an x here, I know that that's part of it. But understand, you also need to factor out your coefficients. Okay, now the GCF, which is the greatest common factor, right? It's a factor between the numbers, right? I'm technically multiplying here. I've got 2 times x times x. Over here, I've just got 4 times x. Okay, and so since both of these I'm multiplying x, I can pull out that factor of x. So I've pulled out x so far. But note, right, that 2 and 4 also have a greatest common factor. Okay, let's talk about all the factors of 2. It's only 2 and 1. Okay, and in fact, we're not going to write it in that form. Let's go ahead and write it as like 2, and then we've got 1 and 2. Those are my factors of 2. Okay, let's talk about my factors of 4. I've got 1, okay, I've got 2, and I've got 4. Well, which is the greatest out of these numbers? That's 2. All right, they both share that. So that's why it's my greatest common factor. So I'm going to pull that out, and then I'm going to kind of undistribute. That's how I like to think about greatest common factor, is I'm undistributing a factor. And then this particular factor that I'm undistributing is 2x. Okay, so I end up with x here, and then plus 2 here, and then equals 0. Okay, now the reason why I like to call it undistributing is because if I were to go from this step back up to this step, how would I get there? Well, I would distribute the 2x. Okay, so just keep that in mind. That's kind of why I like to call it as undistributing. When you factor out a GCF, you are undistributing whatever that factor is. Okay, and then from here you split, right? So this is like one factor, right? These are each called factors, so it's a factor of 2x between this and a factor of x plus 2. So I've got 2x is equal to 0, and I've got x plus 2 is equal to 0. Okay, notice the reason we can do this is because they're separated by multiplication in the middle here. Okay, and then if I'm solving, I've got x is 0, and I've got over here, right, minus 2, x is negative 2. Perfect. And so that would be your answer on that one. Okay, let's see. All right, let's continue on with some examples. Okay, let's say I have something like this. X squared plus 8x plus 16 is equal to 0. Okay, now you've got options here. Okay, you've got options. You can treat it like it's this. Okay, like it's your normal 3-term trinomial, right? Where you know, the n times the end is equal to c, and then the n plus the end is equal to b. You can treat it like that. Okay, or you can notice that this is actually a perfect square trinomial. Okay, and you have to be a little bit understanding of this process very well to kind of see that. Okay, or you can just kind of understand the fact that, well, let's think about it. 16, that's a perfect square, right? I could take the square root of 16 and get 4. Okay, and then what ends up being 4 plus 4? Well, 4 plus 4 is 8. Okay, so if you can see that kind of pattern, it will help you a lot, like a lot of times, right? Like it'll help you further on in this class in various topics, and it'll help you just further on in math in general. Okay, so I notice that this is a perfect square trinomial because I see that the square root of 16 is 4, and that 4 plus 4 is 8, so I can actually go ahead and just say, boom, that right there. Okay, if that's not the case, okay, you could have also said x plus 4, okay, times x plus 4. Maybe you did that process with the 2 parentheses, okay, and then you kind of worked your way there and noticed that oh, look at that, it ends up being the same. Okay, when it is the same, you only need to split it once. I mean, if you could split it twice, but you're going to get the same thing both times. Okay, so you just need to get x plus 4 is equal to 0, and if you're solving, minus 4, okay, so you get that x is 4. And again, you can do it twice, but it's the same thing, right? You still just get x is equal to negative 4. So that's a perfect square trinomial. Okay, that is a perfect square trinomial, so we kind of used the perfect square factoring to get x plus 4 quantity squared. Okay, maybe a little bit of a tougher example. Let's look at this one. X to the 4th minus 2x squared, and then plus 1. Okay, so I'm kind of looking at this one and I'm thinking about, what form is this in, okay? And if we were to use our flow chart, GCF, okay? No GCF because I have that constant. Difference of squares, well, it's not 2 terms, so I'm not even looking at that. 3 terms, okay? Is it a perfect square trinomial? Well, it doesn't have that adding here, so it's not this one. It does have the subtracting here, so maybe it's that one, okay? We could try this if you want, and then this right here, it's not in this because it doesn't have a different a value, okay? So you've got 2 options. You're either doing this or this. You could get it from this, but I just want to show you that this is actually the perfect square trinomial example when you've got the a minus b, okay? Now, the x to the 4th might trip people up a little bit, but what you end up doing is you have like this, x squared and then x squared, okay? So that kind of gives you that x to the 4th, all right? And then this particular one happens to be minus 1 and minus 1, okay? Or you could write it like this, all right? And all that equals 0. You've got 2 options here, okay? So maybe you're kind of fiddling with it and you find this, okay? But you could also jump to this immediately, all right? So anyways, if we're trying to solve for this one, the biggest point I'm trying to make here is that this is a perfect square trinomial in this form, where your a is x squared, okay? Look, right, your a, all right, it's the first one here, minus, okay? And then your a is x squared, and then we got minus, and this is the example where your b is 1, okay? And then in order to solve this one, you're technically splitting, but there's no point to split, so you just end up with x squared minus 1 is equal to 0. Add 1 to both sides. You get x squared is 1. And then x is equal to positive or negative 1. Okay? So that's what we get there. Okay? Which is really silly that I wrote it that way. I didn't do the last step, right? So what is the square root of 1? That's 1. So it's x is equal to 1, but also x is equal to negative 1. Okay? Either of those would work. Except for these. All right, next one. Okay, we've got, let's do one like this. Yeah, let's do this one. This is a good one. Okay, x cubed minus 10x squared, and then plus 21x equals 0. So I'm looking for when that is equal to 0. Okay, again, I'm using my flow chart. Okay, first step, always look for and factor the GCF. So I'm looking through at each of my terms, and I'm asking myself, do I have a GCF? Okay, so I'm looking here, I've got an x cubed term. I'm looking at this one, I've got an x squared term. I'm looking at this one, I've got an x term. Okay, so I do have a GCF here. All right, they each have x. So I'm going to go ahead and pull that out. Pull it out, right? And then you see what's left over. You're undistributing, right? What you're asking yourself in order to write what's in here is x times what will give me that. Okay, well, x times x squared will give me that. Okay, and then on the next one, I know it's going to be negative. X times what will give me that? Well, that's 10x. Up here, x times what will get me this up here? That's 21. Okay, so I've got a term of x here. Okay, I'm going to leave that out for now. And then notice what we're left with. We're left with a trinomial. So I can now factor this, because I want to factor the whole thing. I want everything to be factored out first, and then I'll solve for x. Okay, so I want to factor this, and then, again, with practice you get very good at this, right? But I'm noticing immediately, because I have a negative, okay, I know I'm going to have, because I have a negative here and then a positive here, I know I'm going to have two negatives. So I'm looking at this immediately and saying, yep, I've definitely got two negatives, right? Because the only way to get a positive and then a negative here is to have a negative times a negative, which will give me a positive, okay? And then I'm adding these two together to think about what that would be. Think about the factors of 21. You basically got 1 and 21, and then you've got 7 and 3. Okay, so I know I end up with 7 and 3 here. Okay, and think about what we're doing, right? Negative 7 times negative 3 is positive 21. But when I add these two together, right, when I've got negative 7x and then negative 3x, I end up getting that negative 10x. So this is my fully factored form. Okay, and now we're splitting it into three parts. I've got x is 0, that's this one. Okay, and then over here I've got x minus 7 is 0, therefore x is equal to 7. Over here I've got x minus 3 is equal to 0, and I've got x is equal to 3. Okay? Now the reason we do that, just to kind of tell you why, like maybe I don't want you to just kind of follow me blindly. Why am I splitting it up and solving it like that? Well, the answer is, in order for something to be 0, one of these three things has to be 0, right? So that's why we typically have 0 on the other side when we're factoring. Okay, because either this is 0, right? Let's think about it. If we plug in 0 here, that's 0, okay? I don't care what this is. 0 minus 7, okay, that's negative 7. Well, 0 times negative 7, 0. 0 minus 3, negative 3. I don't care, again, because I started off with that 0. If I plug in 7 here, I get 7 minus 7. That's 0. Okay, I don't care what the other two are when I plug them in. The whole thing is 0. And then same with the 3. 3 minus 3, right? I get a 0 for this term, or for that factor. I don't care what these two are when I plug in x. The whole thing will be 0. Okay, so that's why you solve for that. Again, all we're doing is what values of x